very conceptual problem from limit of a function, right? And this is very common problem of all competitive exam. Limit x tends to 0 sine 1 by x, which is 4 option 0, 1, infinity does not exist. Okay, the answer is no, this is does not exist. D is the correct answer. If there be an option, this is oscillatory, then this option is correct. Okay, then does not exist are not in the option. If there be option oscillatory, then oscillatory is the correct option. Okay, now our problem is how to say the does not exist or oscillatory is the correct answer. Here we use an important property or important theorem of limit of a function, which is known as Cauchy's criterion for existence of limit. This is also known as Cauchy's general principle of limit, right? And this principle says that this is very important and strong theorem because this is necessary and sufficient condition that this limit exists as x tends to a and the limiting value is L. Is that for any pre-assigned epsilon greater than 0, however small it may be, there must exist a real delta greater than 0 such that fx2 minus fx1, the value of these two functional value and the difference is less than pre-assigned number for every pair of x1, x2, but which are satisfied these two conditions. At the point A, it must be x1 minus a less than delta or x2 minus a less than delta. That is, we say these two conditions another way, that x1 and x2, these 2 points must be in the neighborhood, delta neighborhood of A. Okay. Now, how to find or how to solution give for this problem? Here we consider, we first let here A, this is equal to 0. Okay. So, here we take 2 points near 0. Because we have to find out 2 point x1, x2 in the neighborhood of A, that is in the neighborhood of 0. And we consider neighborhood, delta neighborhood of 0. And that is, the neighborhood is given by 0 minus delta, 0 plus delta. Okay, that is minus delta, 2 plus delta. And consider here 2 points x1 and x2. We consider 2 points, this is 2 by 4n minus 1 into pi, and another point is 4n plus 1 into pi, where n this is belongs to natural number. And clearly, if we taking large value of n, then this and this both gives the smallest value. That is, as n tends to infinity we take, then x1 and x2 are both tends to 0. Okay, so for large value of n, it is clear that x1 and x2 both are belongs to n delta 0. This is the first point. Now, if we find the value of f of x1, this is given by sine of 1 by x1. This is given by sine of 1 by 2 by 4n minus 1 into pi. So this is sine of, this is given by 2n pi minus pi by 2. And clearly 2n pi minus pi by 2 for any value of n, this is lies in the fourth quadrant. Okay, so this is all sine, tan, cos. This is the quadrant of cos. So we get this value is minus 1 because this is sine pi by 2 or minus sine pi by 2. And similarly, f of x2, we directly write this result. This is sine of 2n pi plus pi by 2, and this value is 1. Now, if we find the value of f of x1 minus f of x2, then we get this is minus 1 minus 1. So this is mod of minus 2, this is 2, and clearly if we take epsilon less than 2, then clearly this value is greater than epsilon. Okay, so our this condition is not satisfied by these 2 points, but these 2 points must belongs to the delta neighborhood of 0. So our definition of Cauchy's criterion or general principle is not satisfied by the function. Okay, so our answer is the limit is does not exist. Okay, and how to say this is oscillatory? Because in 2 points x1 and x2, these 2 points are very close, but the value of these 2 points, one point is 1 and one point is minus 1. So we say that this limit is oscillate between minus 1 and plus 1. Okay, but we cannot get the definite value of this limit. So we say that this is oscillatory limit, or the value is oscillate between minus 1 and plus 1. Okay, very conceptual and very interesting problem of limit. Thank you for watching.